You're at a convenience store, you grab a cold can of soda, and you pull that little metal tab to crack it open. The satisfying pop, the hiss of carbonation escaping, and you're ready to drink. It's such a routine action that you've probably done it thousands of times without giving it a second thought. That little metal button on top of the can seems simple enough. Pull it back, it opens the can, end of story. But here's something that might surprise you. That tab is doing far more than just opening your drink. It's actually a masterpiece of engineering that solved multiple problems at once, and it has features built into it that most people never notice or use. In fact, that tab went through decades of evolution, caused environmental disasters, sparked innovation, and even has a hidden function that's printed right there on many cans, but almost nobody knows about. The story of the soda can tab is a story about design, safety, convenience, and how one small piece of metal changed the way billions of people drink beverages. Let's explore right here on History of Simple Things. Before we talk about why the tab exists in its current form, we need to understand what came before it, because the history of opening soda cans is surprisingly dramatic. When aluminum cans first became popular in the 1960s, they didn't have tabs at all. They were sealed shut completely, and you needed a separate tool called a church key, essentially a pointed can opener, to punch two holes in the top. One hole to pour from, and another to let air in so the liquid would flow smoothly. This was messy, inconvenient, and meant you always needed to carry an opener with you. If you forgot your church key, you were out of luck. The beverage industry knew this was a problem, and they were desperate for a solution that would make cans as convenient as bottles with twist-off caps. The breakthrough came in 1963 when a mechanical engineer named Emil Frese invented the pull tab, also called the ring pull. Frese came up with the idea after he forgot his can opener at a family picnic and had to use the bumper of his car to open a can of beer. Frustrated by the experience, he spent the next few months designing a can that could be opened without any tools. His solution was elegant: a metal tab attached to a pre-scored section of the can's lid. You'd pull the tab, and it would tear away a piece of the aluminum, creating an opening. The tab and the piece of metal it removed would come off completely in your hand. This was revolutionary. For the first time, you could open a can anywhere, anytime, with no extra equipment needed. Pull tabs became wildly popular almost overnight. By the late 1960s and early 1970s, they were everywhere. But they created a massive problem that nobody had anticipated: litter and injuries. Because the tab and the piece of metal came off the can completely, people would just drop them on the ground. Beaches, parks, and streets became littered with sharp pieces of aluminum. Even worse, the tabs were dangerous. People would accidentally step on them with bare feet, getting cut by the sharp edges. Some people would drop the tabs into the can before drinking, and then accidentally swallow them or cut their lips on the sharp metal. There were reports of serious injuries and even a few deaths from people choking on the tabs. The environmental and safety problems became so severe that several U.S. states began considering bans on pull-tab cans entirely. This crisis forced the beverage industry to innovate again, and in 1975, a design engineer named Daniel F. Kudzik, working for Reynolds Metals Company, invented what we now use today: the Stay Tab, also called the Stay-On tab. Instead of removing a piece of the can lid, Kudzik's design pushed a pre-scored section of the aluminum down into the can, creating an opening while keeping everything attached. The tab stayed connected to the can, eliminating the litter problem. Within a few years, Stay tabs had almost completely replaced the old pull tabs. By the early 1980s, they were the standard. This is the tab you see on virtually every can today, a simple piece of metal that's permanently attached and pivots on a rivet. But here's where it gets interesting, because that tab does more than just open the can. Let's talk about the engineering that makes it work so well. The tab operates on the principle of leverage, one of the oldest and most fundamental concepts in physics. The tab is essentially a lever with the rivet acting as a fulcrum. When you pull up on the short end of the tab, the long end presses down on a pre-scored section of the aluminum lid with much greater force than you're applying. This mechanical advantage means you don't need much strength to puncture the aluminum. The scoring on the lid is precisely engineered, deep enough that it tears easily when pressure is applied, but not so deep that it weakens the structural integrity of the sealed can. The shape of the opening is also carefully designed. It's large enough to drink from comfortably, but not so large that it compromises the strength of the lid or makes the carbonation escape too quickly. The rivet that holds the tab in place is another critical component. It has to be strong enough to withstand the force of opening the can and the repeated flexing if someone lifts the tab up and down, but it also has to allow smooth rotation with minimal friction. Modern rivets are formed by a process called staking, where the two layers of aluminum are pressed together and deformed to create a permanent mechanical connection. The rivet is designed to be slightly raised, creating a small gap between the tab and the lid, which reduces friction and makes the tab easier to operate. All of this engineering happens at a scale of millimeters, and every aspect is optimized for manufacturing efficiency because these cans are produced by the billions. Now here's the feature that most people never discover, even though it's sitting right there on top of the can. That tab can be rotated 180 degrees after you open the can, and when you do that, the hole in the tab lines up perfectly over the opening in the can. This isn't accidental. It's specifically designed to hold a straw. If you look at many cans, especially in certain markets, you'll even see instructions printed on the top that say, "Rotate tab to hold straw," or show a little diagram. The idea is that once you've opened the can, you twist the tab around so the hole faces the other direction, and then you can insert a straw through that hole. The tab holds the straw in place, preventing it from floating around or falling out. This is particularly useful when you're in a moving vehicle or when you want to keep insects from getting into your drink at an outdoor event. It's a simple, clever feature that requires no additional parts and costs nothing extra to manufacture. Yet the vast majority of people have never used it, or even know it exists. There are other subtle design elements in that tab that most people never notice. If you look closely, you'll see that the underside of the tab, the part that presses down on the lid, often has a specific shape. It's not just flat. It's usually got a rounded or beveled edge that's designed to concentrate force on a small area of the scored section, making it easier to puncture. Some tabs also have textured surfaces or ridges on the top where your finger goes, providing better grip and reducing the chance that your finger will slip off when you're pulling. The length and angle of the tab are carefully optimized too. If the tab is too short, you don't get enough leverage and it becomes hard to open. If it's too long, it becomes flimsy and might bend or break before opening the can. The angle at which the tab sits when the can is sealed is also important. It needs to be high enough that you can easily get your finger underneath it, but not so high that it catches on things or takes up too much space when cans are stacked. The material science involved is equally sophisticated. The tab is made from the same aluminum alloy as the rest of the can, but it goes through different manufacturing processes. The can body is typically made from a softer aluminum alloy that can be drawn and formed into shape easily, while the lid and tab need to be made from a harder, more rigid alloy that won't bend or deform during normal handling. The thickness of the aluminum in the tab is precisely controlled, usually around 0.25 millimeters, which is about twice as thick as the main body of the can. This gives it the strength and rigidity needed to function as a lever while still being thin enough to keep weight and material costs down. The scoring on the lid is created by a process that removes about 70 to 80% of the aluminum thickness in a precise pattern, leaving just enough material to maintain the seal until the can is opened. Manufacturing these tabs is an incredible feat of mass production. Modern can-making facilities produce tens of thousands of cans per hour, and every single one needs a perfectly formed, perfectly attached tab. The tabs are stamped from sheets of aluminum using high-speed presses, then attached to the lids with automated riveting machines that can complete the process in fractions of a second. The precision required is remarkable. If the rivet is too tight, the tab won't rotate smoothly and will be difficult to operate. If it's too loose, the tab might fall off or not apply enough force to open the can. The scoring has to be consistent within micrometers, or some cans will be impossible to open while others might leak or burst. Quality control systems use cameras and sensors to inspect every can, rejecting any that don't meet exact specifications. The environmental impact of the switch from pull tabs to stay tabs was enormous. It's estimated that the old pull tabs generated tens of thousands of tons of aluminum litter every year in the United States alone. The stay tab design eliminated virtually all of that overnight. But the environmental story doesn't end there. Aluminum is one of the most recyclable materials ever created. About 75% of all the aluminum ever produced is still in use today, having been recycled multiple times. When you recycle a can, the aluminum from the can, body, lid, and tab all get melted down together and can be turned into new cans within 60 days. Recycling aluminum saves about 95% of the energy needed to produce aluminum from raw ore, making it one of the most environmentally beneficial recycling processes. The stay tab design supports this by keeping everything together. There are no small parts to separate or lose, making the recycling process more efficient. There have been continuous improvements to the tab design over the decades. Some modern tabs are wider and easier to grip, especially for people with arthritis or limited hand strength. Some have been redesigned to require less force to open, making them more accessible. There are specialty designs for different types of beverages too. Energy drink cans often have smaller openings because people typically consume them more slowly. Some beer cans have larger openings designed for a faster pour. A few experimental designs have tried to create resealable cans with tabs that can close the opening again, though these haven't become mainstream yet due to cost and complexity. The tab has also become a cultural object in its own right. For decades, there's been an urban legend that collecting pull tabs from cans was somehow more valuable for recycling than recycling the whole can, leading to massive collection drives, especially by schools and charities. This isn't actually true. The tabs in the can are made of the same aluminum and have the same recycling value per pound, but the tabs are easier to store and transport in large quantities, which is probably why the myth persists. Some people collect tabs as a hobby, sorting them by color, shape, or brand. The tabs have even been used as a form of currency in some subcultures, and there are numerous craft projects that repurpose them into jewelry, art, or useful objects. The simple soda can tab represents something important about engineering and design. The best solutions are often the ones you don't notice. Nobody thinks about the tab unless it breaks or doesn't work properly. When it functions as intended, it's completely invisible, just part of the seamless experience of opening and drinking a beverage. But that invisibility is the result of decades of iteration, countless hours of engineering work, billions of dollars in manufacturing infrastructure, and lessons learned from both successes and failures. The tab on your soda can is a small object, but it's connected to a vast system of design, production, distribution, and recycling that spans the entire globe. So the next time you crack open a cold can of soda, take a second to appreciate that little metal tab. It's not just an opener, it's a carefully engineered lever that uses mechanical advantage to make your life easier. It's a safety device that eliminated a significant source of injuries and environmental damage. It's a straw holder that most people never use, but that demonstrates thoughtful, anticipatory design. It's a triumph of mass manufacturing that's replicated billions of times with astonishing consistency. And it's a reminder that even the most ordinary objects around us often have extraordinary stories, layers of complexity and innovation hiding in plain sight, waiting to be discovered by anyone curious enough to look closer. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution.